My name is Sarah Walls. I'm a PhD student in Martin Grosell's lab. And the main question for this study is how ichthyocarbonate is affected by body size and feeding state of marine fish. And so ichthyocarbonate is a mineral that is made in the marine Teleost intestine. And it is made as an osmoregulatory product, so they make it so that they can balance water in their bodies. And the questioning here with body size and feeding state is that if you increase body size and you decrease feeding in marine teleosts, you're going to decrease the mass-specific metabolic rate, which decreases drinking rate and osmoregulatory demand. And so if you're decreasing osmoregulatory demand, the osmoregulatory product may be affected in its composition. And magnesium is important for us in particular because magnesium can affect how ichthyocarbonate acts after it's excreted. So once it's excreted into the marine environment, magnesium can determine whether it dissolves in the upper oceans or if it ends up in the sediment of our oceans, and that can determine how the ichthyocarbonate plays in the marine carbon cycle. So what we find is that when you fast fish and you have larger fish, they have a much higher magnesium content in their ichthyocarbonate. And we were wondering if the reasoning behind this is because of the intestinal fluid of the marine teleost. And we find that the marine teleost intestinal fluid does not really have any ionic changes between larger fish or fasted fish. There's really no difference significantly in the ionic composition of that intestinal fluid. And I'm just showing calcium here as an example. And so the mechanism behind how this actually works is that if you are going to reduce drinking and fluid ingestion, the fish has to do with that fluid a lot more than it would have to do if it were drinking a ton and had a lot of fluid to work with. So it's going to increase fractional fluid absorption so that it can take up as much water as possible from that smaller volume that it's taking in. And the way it's going to do this is it's going to increase the magnesium in its ichthyocarbonate so that it can lower the osmotic pressure of that intestinal fluid to be able to take up more fresh water. And when you increase fluid absorption, you have a balance here between two things. You have the increase in magnesium and calcium in ichthyocarbonate and the increase in magnesium and calcium in the intestinal fluids. And so between those two things, we don't see a significant difference in the calcium and magnesium in the intestinal fluids between body sizes and feeding states. And so this is important for our marine carbon cycles because marine fish could be contributing to the carbon cycle in different ways throughout their entire life. So while they're changing in their body size and they're changing in their feeding state, they could be altering the ichthyocarbonate that they're making, and that could be changing the carbon cycle. Thank you.